Good morning, everybody. Today we're going to start talking about ionic compounds in our class notes. So let's talk about that. So remember, ionic compounds are one of the three different ways that elements can combine together. We have ionic, covalent, and metallic. And ionic compounds are always going to be the bonding between a metal and a non-metal. And it tells us two different things, these chemical formulas. So if we look here, we can see that it tells us two things. The two things it tells us, one is what elements make it up. It's made up of sodium and oxygen. The subscript 2 here tells us the ratio that they're combined together. There are 2 sodiums and 1 oxygen in this compound. And the reason that there's 2 sodiums, we'll find out as we talk along here, is that we want this overall compound to have a charge of 0. And the charge that we're talking about is everybody wants to have 8 electrons in the outermost shell, what we've talked about in the past. Another way of ionic compounds to be talked about is they'll be called a formula unit. Covalent compounds will be called molecules. And monatomic ions is sodium is monatomic because there's just one of these. Oxygen, there's just one of these. So these are monatomic, and combine these together, these make a binary compound. Remember, binary is a fancy word for 2. So this is a binary compound because it's made up of just 2 different elements. We're not talking about the amount, we're talking about the difference of them. So there are 2 here with sodium and oxygen. Tomorrow, we'll start talking about polyatomic, which means there are several different elements, 2 or more, that'll be in here. These oxidation numbers here, these are the number of electrons that it needs to do to get to 8 in the outermost shell. We've talked a little bit about this in the past. Sodium is a +1 because it has an S1 subshell. It has just 1 electron in the outermost shell. It gives that one away, so it now has more protons than electrons, hence the positive charge. Oxygen has 6 electrons in its outermost shell, so it needs 2 more to get to 8. When it grabs those 2 more electrons, it now has 2 more electrons and protons, hence its negative charge. We have some rules for writing these ionic compounds. We have calcium chloride up here at the top. When we write the chemical symbols, write them like this. Write first the metal before the non-metal. Then look and find the charge of the ion. So I look and see that calcium is in the 2nd column of the periodic table. I know everything in the 2nd column is a +2. Chlorine is in the next to last, the halogen ones, right next to the noble gases. It's in column 17, and it has everything in that column is a -1. That is its oxidation numbers. I want these values to turn out to be 0, which means this has to give away 2 electrons. This can only take 1. Chlorine can't take 2. So what happens is I want these charges to be equal to 0 overall. So I have to multiply chlorine by a 2 to get to a -2 right here to add them together. So the overall charge of the compound itself needs to be 0. And to show that I use 2 chlorines, I put the subscript down here. We'll also notice that we don't bother to write 1. I don't need to write 1. That's redundant. By listing calcium here, obviously there is at least 1 of them. So let's look through some examples. And I'm going to go and do this a little bit different. I'm going to share a different screen. So when I'm talking about these charges again, remember, I'm looking at my periodic table. Everything in the first column is a +1. +2, these are my oxidation numbers. Everything here is a +3. with carbon, this is plus or minus 4, minus 3, minus 2, minus 1, and we know these have 8 electrons in the outermost shell. So our noble gases are 0. So if I go to potassium chloride, sulfide, I know potassium is in the first column. It's a +1. Sulfur is in the same column as oxygen, and everything is a -2. So basically, I'm saying what times this 1 will get these equal to 0? Well, it has to be a 2, because that would give me a +2 here to 0. So it is that. If I go to iron, pause the video if you need to and see if you can do this yourself. But we do have something new here. This is our Roman numeral. It tells me the charge. We know already that iron could be a +2 or a +3. We learned that last chapter. This case, it's a +3 because it has a Roman numeral with it. So when I do this, I have that. Well, just adding those together, I would get a -1. That's not going to work. But if I take this times 2, I get a +6. If I take this times 3, I get a -6. That equals 0. So I had iron like that. And that is my balanced one. Here, I have that. And I end up with that. All right, so let's go on to the other way. What if I give you the names, or the compounds, I'm sorry. What if I give you the compounds? Here, I want to be able to go backwards. Well, the metals always get the full name. The non-metals, and you've already been doing this, if I gave you NaCl, you would automatically say sodium chloride. You wouldn't say sodium chlorine. That just sounds funny. So what we do is we give the beginning of the name and then we add IDE. We get here, now we have another case. We have to always check when we're naming these if the metal is a transition metal. Is a transition. Remember, transition are my ones from here to here. These are my transition ones. And these ones can have multiple charges. But to make your life easy, I told you to download this chemical information sheet, and that is on today's part of our assignment. You can download this. If you go down to the bottom here, it tells you the charges of metals. And we know everything in group 1, that's a column 1, is a +1. Here are some of our transition elements right here. So you can always use this on tests and homework. I don't expect you to memorize any of these. And I see silver always has a +1 charge. Zinc always has a +2 charge. Here we go. Iron can be a +2 or a +3. And notice all of these other ones are like this. So I'm saying that I can have a copper like that. Or a copper 2. So I need to always check if my metal in my naming is a transition ones, I have to figure out which one it is. And how I do that is doing the math backwards. So I know in this example that iron is a transition one. So if I want to do this backwards, what I do is oxygen we know is always a -2. So we always look at the non-metal in this case. It's always a -2. And I need to know what, and I have just one of them, what this X is to equal 0. X has to be a +2, right? 1 times a +2 plus a -2 is 0. So this means this is iron 2, and I add IDE. It is iron 2 oxide. So why don't you pause the video and try to see if you can name this one. This one, copper is a transition. I always want to double check on my chemical info sheet, which if these are transitions or not. I can look and see copper is. So pause the video and see if you can do this one. Okay, copper and oxygen. Oxygen is always a -2. I have 2 coppers. So what times 2, when you add it to just algebra plus a -2 will equal 0? Well, X has to be 1. So this has to be copper 1 oxide. And you can always double check your answers. I can do this backwards and go, oh, if it's copper 1, that's a +1. Oxygen is a -2. That means I have to have 2 coppers to get this to equal to 0. And ooh, I look up there and it worked out. So I can always work my answers backwards to make sure that I did it correctly. See if you can do this one with tin. All right, we know oxygen is always a -2. Tin, there is just one of them. So in this case, that X has to be tin 2 oxide. All right, so you have worksheet A to do, and you should be able to do that. The answers are there for you to check. If you have any questions, you can always click into Zoom and talk to me, but hopefully you have enough information to be able to start doing your homework.